Are astronomers allergic to talking about distances in a normal way? I mean, sometimes we do say something normal like that galaxy is 2 million light years away or that star is 20 parsecs away. But other times, instead of giving a distance, we'll say things like, we're finding this galaxy 300 million years after the Big Bang, or its light has been traveling to us for 10 billion years. Or we'll say what an object's redshift is. And there's a few different reasons why this happens. The first is that sometimes it's useful to talk more in terms of time than distance. Light from faraway galaxies doesn't instantaneously arrive at our telescopes. It has to travel across the universe to get to us. The further away a galaxy is, the longer it takes for its light to reach us. So when we say the light from these galaxies has been traveling for 10 billion years, that does provide a sense of scale. These galaxies must be very far away, and it reminds us that we're seeing them as they were in the past. We're observing the universe as it was 10 billion years ago. Another reason we might use these other descriptions is because defining a distance can be complicated. The universe is expanding. Galaxies are getting pulled away from us, so the distance they were at when they emitted the light we see is not the distance they are at in this exact moment. If we're observing something whose light has taken 10 billion years to get to us, that means it was 10 billion light years away when it emitted the light. But as its light traveled towards us, it was moving away from us, and in this moment, that galaxy is now 16.4 billion light years away. When you read scientific papers, you normally don't see any of this. Instead of talking about distance or time, scientists use redshift. As light travels across the universe, it gets stretched out by the universe's expansion, moving to lower energy or longer wavelengths. Because red light has longer wavelengths, we call this redshifting. The further away something is, the more redshifted its light, because it's been traveling for longer, so it's had more time to be stretched out. You can calculate the distance if you know the redshift, but the math is kind of complicated. It relies on a few other parameters and assumptions, and for the case of most research, is unnecessary. The change in the wavelengths of light is something we actually get from our observations, so it's what's reported in our scientific papers. And you do sometimes see it in press releases or articles for a more general audience. So depending on what you want to understand and what kind of information you have, how this concept of distance is reported can vary. But whether you give a true distance or a time or a redshift, it's all really telling us the same thing.